In this video, I'm going to get started on trying out different techniques for rendering my quads with a vector of motion attached in the shader. I have a lot of different ideas of what might make this work, and if you go to look at the previous video, I kind of outlined in a quick sketch a lot of different ideas that I want to explore, but for this video, I'm going to stick with the absolute simplest one and see how far I can get with just that. So for geometry, there won't be anything fancy. I'm just going to take a rectangle and expand it so that it includes the final position of the rectangle plus the swept locations of the rectangle. The result will be just a larger rectangle that encloses more than the necessary space. And then I'm going to use sampling on each point in that enclosed space. So the sampling will cast a vector that is the same shape as the vector of motion and take several samples along that vector, testing always against the final position of the rectangle. And this way, if I have a pixel that touches several different parts of the rectangle, it'll gather up several samples. If I have a point that only touches one point of the rectangle, but at other time slices didn't hit the rectangle, it'll have a lighter blur, and points that never were touched by the sweeping rectangle will be completely transparent. That's the idea. Let's give it a shot and see how good that can get. Okay, so I implemented the idea that I wanted to, got to play around with it a little bit, and it occurred to me pretty quickly that one thing it's going to do is it's going to reintroduce the actual aliasing that I was originally trying to solve. And it's kind of maybe confusing why this is happening. If the whole point of introducing motion blur is to fix the aliasing, why is it coming back? But it's kind of what I was suspecting when I was sketching this out on the blackboard. The big problem with doing sampling along the vector is that it's just going to reintroduce all the problems of aliasing. Now I have pixels that completely hit and pixels that completely miss very easily, rather than what I had before where I was computing pixel coverage, which allowed me to get pixels that were half covered or a quarter covered very quickly and easily. Now the only way to get a pixel that's a quarter covered is for it to line up in the right way on the timing of a rectangle in motion, but a rectangle sitting still has no way to anti-alias itself. So I need to take a minute and think through how I think the anti-aliasing will really work in connection with things that are sitting still as well as things that are moving. So once I've had a minute to think, I'll come back and let you know what I want to try next. Okay, I've got a pretty good idea of what went wrong there, and I think I have a fix. So first of all, let's think about what did work in the previous version before I started doing this motion blur along a motion of vector, or a vector of motion. So what I was doing to get the anti-aliasing before was I was calculating the exact pixel coverage for each pixel. And all I was doing to do that was taking the rectangle, which is actually a square, but the rectangular area that covers one pixel, and then I was intersecting that using a simple rectangular intersection concept with the rectangle I was trying to render and finding out what the amount of the pixel that was covered was needed to be for each pixel, right? By looking at that intersection, I could just take an area. So then I abandoned that idea and went to this sampling of points idea, where I have a starting point and then I move along a vector taking each point and testing, is this in the rectangle, yes or no? And so then I end up with 4 yes or no answers and I blend them together. The problem with that is when I have a line that's sitting still, now I'm getting either all ones or all zeros. Since I have a velocity of 0, all of a sudden they either all hit or they all miss. And so I'm right back to completely anti-aliased shapes at that point, right? I mean, I'm just sampling 4 times from the same position, blending them together, and using the exact same logic besides that you would have gotten with no anti-aliasing at all. So my idea then is, what if I use that idea of area that was making the original thing work, right? So I was taking a pixel, intersecting that with the primitive, and calculating the area of that intersected rectangle. So what if I did the same procedure where I'm going to sort of shade in the intersecting area, but I put the box that I am intersecting, instead of around the entire pixel, I put it around each of those sample points. So I'm going to still cast out 4 sample points along the vector to sort of sweep the direction of motion. But instead of just putting down a point and saying, is this in the rectangle, yes or no, I'm going to use that point as the center for a pixel-sized box and then grab that 4 times. So I'll have to do 4 of these rectangle overlapping things instead of 1 of them. But if my pixels are sitting still, this will do what it's supposed to do. It will behave just like it was when it was sitting still before with a single sample. And it will actually make the correct thing happen when I have motion in a particular direction of like a speed of 1, for instance, where before I would have had all 4 samples just outside of the primitive. Now, as the samples get closer, they'll start having their boxes overlap with the edge of the primitive, and I'll get a little bit of area so that I will actually get a motion blur on something slow, like at a velocity of 1. So let's give that a try now. I'm pretty happy with how this is looking right here. It does seem like I'm going to probably want to end up clamping the velocity, and not just because it would make it easier to do the geometry or easier to do the sampling with enough precision, but just because when the tail gets long enough, the blur does start to look silly, like it becomes more obvious that there's something weird going on. Even without any motion blur, there is still a sense when things are moving very fast that you can see that motion blur, even though you technically are just seeing a bunch of still frames with no motion blur. And we're not actually doing any of this to get an effect of motion blur. The whole point is to help with those slower moving things so that they don't have that sort of choppiness in those pixels as they move. And, specifically with the slow moving, smallest possible rectangles. And so putting in extra compute to create an effect that I don't even want is really silly. And so I think I'm going to just go ahead and say we do want to, just for aesthetic reasons, have this clamp, not even for computational reasons, which I hadn't necessarily anticipated. But now that I've tried that out, it's nice to know that we'll probably just assume a clamp for aesthetic reasons, unless one of these blurs ends up looking just right without it for some reason. But of course, we're not even ready to start trying out with other blurs yet. So what we've done so far is found an okay way to test out this idea of sampling along the line, and I do think it would work pretty well. What I haven't done is I haven't figured out how to do this with color gradients, UV coordinates, rounded corners, or outlines with variable thickness. So that's what we're going to try next. We're going to see if we can find some way to blend the ideas here with the necessary ingredients to get all of those features working. So you can join me next time to check out how that goes. See you then.